Hello everyone, hope you're all doing good. So today we are here for grade 8 maths. The chapter today we discuss that is probability, and here are the list of the lessons. So the first lesson today we cover that is identify the independent and dependent events, probability of the sample events, probability of opposites mutual exclusive and overlapping events, make predictions and compound events, find the number of outcomes. You can find all the lessons on aplusstudent.com. You have to log in by using the email and passwords that are provided by the administrator. Select Maths from the subject tab, scroll down to the grade 8. There are the list of the chapters, and we are on the chapter probability. Let's open this. And here we cover the last lessons. So, dependent, identify the independent and dependent events. So, what are dependent and independent events in probability? So first of all, we can see these one in probability. What are the independent events and what are the dependent events? Okay. So independent events are those where the outcomes of one event does not affect the probability of another event. Okay. That means I'm going to write it. I'm going to just write it down here. Independent events. Independent events in which the outcomes of one event. Okay. Outcomes of one event does not affect the doesn't affect the does not affect the probability of other event. Okay. And conversely, dependent events are those where the outcome of one event does influence the probability of another. Okay, these are two just basically and when you are just going to write down the dependent events. Okay, dependent events, it's just like outcome of one event does affect or does influence the probability of an other event. Okay, this is just a basically definition of dependent and independent events. So independent events are outcomes of one event does not affect the probability of another, and conversely dependent events are those where the outcome of one influence the probability of another. Let's suppose, for example, here is a coin. Okay, I'm just going to toss a coin and then rolling a die. So the result of coin toss does not change the probability of rolling any particular number of on the die. Okay, so when we calculate the probability of both, so independent events occurring, you multiply their individuals probability. Understand, this is independent events. And let's suppose for the dependent events like drawing two cards from a deck without any replacement. All right. And when the probability of drawing a specific card on the second draw change based on what card was drawn first. This is the way that we calculate the probability. You need to consider how much change the probability of second based on the outcome of the first. So this is just a basically a little bit understanding about the, you can say that, uh, dependent and independent events. Let's suppose a gumball machine is filled with a mixture of indigo and white gumballs. Uh, uh, Sorry about that. I was just checking my mic and everything. So, a gumball machine is filled with a mixture of indigo and white gumballs. Okay, there are two kinds of mixture. One is indigo and then white. Hallie purchases a gumball and then Jenny does. And these two events dependent or independent? The two events are dependent. Why it's dependent? Because we have two mixtures of. So, a gumball. Why these two events are dependent? Because look at here, the gumball Hallie receive affect which gumballs are left in the machine for Jenny to get. Okay, they are saying that he purchases a gumball because a gumball machine is filled with these are two mixtures, indigo and the white gumball, and they are not saying that like it's basically purchase a white or the indigo. Okay, so there is only one ball, so this is the dependent event. Now look at here, Cindy picks a card at random. There are different cards, and then they are picking a random. All right. And then pick another card at random. So anything that is randomly, so we can say that it is independent event. So these two events are independent because we don't know if the outcomes of the first event does not affect the outcomes of the second event. All right. Maybe in the first, when it drowns, and then puts it, basically pick a card that is blue, and then put it back, and then again choose a card and then pick again the navy blue. So these are two independent event, because it doesn't depend like these two cards are same or all things. Okay, so hope you guys understand this lesson. So these are the dependent and independent events, and I already explained the definitions as well. Okay, probability of simple events. How to find the probability of the simple events? You pick a card at random. There are four cards that are 5, 6, 7, and 8. What is P of 6? Okay, probability. So the total, how many total cards are there? There are four total cards. Okay, and how many cards which are six? There is only one card. So you put up chosen card. Okay, so what is the probability? Probability of six is chosen card over total number of card. So there is, we choose only one card, and there is total number of card is 4. Okay, so the answer is 1 by 4. If let's suppose I am going to, so there are the total cards here, and then these are the total cards. So what is the probability of P of 2? So how many total card? 1, 2, 3, 4, 5, 6. So we are putting 6 in the bottom. And how many cards which are 2? That is only 1. So this is put it like here. So 1 by 6 is your answer. Okay. Now there are 8 tables set up for a banquet, of which 2 blue tablecloths. There are 8 tables set up for the banquet. How many tables that are set up for the banquet? These are 8. Okay, 8 tables. So these are total, and which 2 are blue. So selected number you are putting on the top, and total number you are putting in the bottom. So 2 by 8, and that is your probability. These are very easy. Okay, let's see this question. Kara is picking out the fabric for her bedroom. Kara is picking out fabric for her bedroom. She has 9 fabrics simple, and 3 of them are checkered. Okay, so 9 fabrics that are samples. These are total, and which of 3? 3 of them. Okay, so probability is total 3 by 9. So when you're going to more divide 3 times 1 is 3, 3 times 3 is 9. So this is 1 by 3. 3 by 9 is also the answer. 1 by 3 is also an answer. Let's do this one next. Let's discuss the test questions now. You guys tell me the answer. You pick a card at random. What is probability of 6? Simplify your answer and write it as a fraction or whole number. So first of all, tell me how many total cards are there? There are total 4 cards. Okay, and how many cards which are 6? Only one. So the chosen number we are putting on the top, and the total number we are putting on the bottom. So it's 1 by 4, and that is here. Let's see the answer, and this is the right. You pick a marble at random. Okay, how many total marble? One, 2, 3, 4, and 5. What is P of yellow? This is only one yellow here. So 1 over how many total? 1, 2, 3, 4, 5. 1 by 5. So they are saying that write your answer as a percentage. So this is 1 by 5. Look at here. Probability of yellow. Yellow is only 1 by 5. Now we are multiplying 1 by 5 times 100. Okay. So in this way you are going to multiply with that 5. So this is 100 over 5. Let's divide 100 over the 5 so you get the answer 20%. Okay, so this is P of yellow is 20%. For percentage, we're multiplying with the 100. That's it. Alice's book collection contained the 18 books, including 4 science fiction novels. 18s are book. How many total book? That are 18. How many science book? That are 4. Okay, 18 are total books. Science books are 4. If the Alice randomly selected a book to read, what is the probability that it will be a science fiction novel? They are saying that including 4 science fiction novels, so it's 4 over 18. Okay, so science fiction novel is basically, so how many probability of science fiction novels? 4 over 18, and you're going to more divide 2 by 9, and this is 2 by 9 is your answer. Okay, and this is the right answer. There are 12 tables at a wedding reception. How many total tables? 12. Two of which have yellow centerpieces. Then what is the probability that a randomly selected tables will have a yellow centerpieces? So 2 by 12. And 2 times 1 is 2, 2 times 6 is 12. So P of yellow is 1 by 6. Hope you guys understand this lesson. Solve the rest of the test questions regarding this lesson by yourself. Now let's start the next. So, probability of opposites, mutually exclusive and overlapping events. You spin the spinner once. This is the spinner, and here it's written on it 1, 2, 3, and 4. So, what is probability of 4 or odd? Okay, probability of 4, and how many odd are there? There are two numbers which is odd, that is 1 or 3. Simplify your answer and write it as a fraction or as a whole number. So, first of all, we are going to finding it out probability of 4. So how much the probability of 4? There is only total are 4, and probability of 4 is 1. So it's 1 by 4. How much the probability of odd numbers? How many numbers which are odd? Two numbers. 2 by 4, so that answer is 1 by 2. Now just add up both these. Or means add up. Okay? Let's do it. Let's suppose I'm going to write it here. For example, I am going to choose this one, okay? So 1, 2, 3, and 4. They are saying that finding it out the probability of two or even numbers. Now you guys tell me. First of all, finding the probability of 2. How many total? These are 1, 2, 3, and 4. How much the even? That is 2. It's only 1. So it's 1 by 4. What is the probability of even numbers? Total is 4. How many numbers which are even? 2 numbers. Now the meaning of or is 2 or even. That means we're going to add up 1 by 4 plus 2 by 4, then 4, 1 plus 2, and that is 3 by 4. So this is the probability that we get it. You pick a card at random, 5, 6, 7, 8. Find the probability of 5 or even. Okay, let's do it. Cards are 5, 6, 7, and 8. 5, 6, 7, and 8. 5, 6, 7, and 8. Okay, probability of 5 or even. So what is the probability of 5? First of all, how many total? These are 4. So we put it here. And how many cards which are 5? That is only 1. Now what is the probability of even? Let's see. There are total is 4 and probability of even is 2. Now let's write probability of 5 or even, which is 1 by 4 plus 2 by 4. So the answer is 3 by 4, and that is your answer. Okay, so this is 3 by 4. This is basically the thing that we have done it. Let's do it. You roll a six-sided die. What is probability of 2 or less than 4? Six-sided die. Probability of 2 or less than 4. So here is the die. Okay, there are different sides of die. This is the shape 1, 2, 3, 4, 5, 6. Okay, so less than 4 is, there are two outcomes that are less than 4. This is 1, 2, and 3. Three possibilities. So probability of 2 is only 2. 2 by 6, and that is 1 by 3. And what is basically 4? Probability of 2 is, it's depend, like, because you are chosen randomly, so it may be not. And for less than 4, that is basically 3, 1, 2, and 3. So 3 by 6. Okay, probability of 2, it depends, because the die that are chosen, that are drawn randomly, so we are not saying that. So this should be at least of 2 or that number. So we can say that this is a basically thing in which the die is rolled 2 or less than 4. 2 is basically it depends, and for 4 it is also dependent. Okay, hope you guys understand this lesson. So now let's discuss the next, which is make predictions. Kendall works at an appliance store. She recently sold 6 dishwashers and 6 other appliances. Of the next 10 appliances Kendall sells, how many should she expect to be dishwashers given the past data? Okay, so how many dishwashers? These are basically total 6 dishwashers. Okay, how many total? They are saying that, and 6 other appliances, and of the next 10 appliances Kendall. So it means that this is 6 dishwashers and 6 others. So that are 12. 6 by 12. Okay. So the experimental probability is 1 by 2. Now when you are going to finding it out, the experimental probability to the, basically we are predict the outcomes of second set of trials. Assuming that the ratio will be the same as in first set of the trials, write a proportion by setting the two ratios equal to each other and then solve it. So 1 by 2 is equals to n by 10. So how can we solve it? So 1 by 2 is equals to n by 10. So we are just separating out this 10. So what we do for that, we are going to multiply both the numbers first of all with 2. 2 times 1 by 2, 9 times 2 over 10. So this 2 and 2 should be cancel out, and here is 1. Then n times 2 over 10. Now both sides are multiplied with 10. 10 times 10, n times 2 times 10 over 10. So this 10 should be cancelled. And now 10 times 1 is 10 is equals to n times 2. Now dividing both side with 2. 2 2 cancel, 2 times 5 is 10. So here the answer is n is equals to 5. Okay, first we are going to cancel it out, this 2 and this 10. So that's why we're multiplying firstly 2, then we're multiplying 10, then in the end we're dividing. All right, so n is 5. If you flip a coin 10 times, what is the best prediction possible of the number of times it will land on the heads? There are two possible outcomes, because when you flip a coin there are two possibilities. It's a heads or the tails. Okay, so when you flip it for once, so it means that there is one possibility for head or tails. So one, and how much total, that are two, because head and tails, these are total outcomes are two. So 1 by 2. So what is the 1 by 2 of 10th? We are going to finding it out. 1 by 2 of 10, so that is 5. So my screen is stuck. Wait, I'm going to share it again. I don't know. So at Tasty Dog, 4 of the last 6 customer wanted the mustard on their hot dogs. Considering this data, how many of the next 12 customers would you expect to want mustard? So we are going to find out. So how many customers we are going to finding it out? Okay, customer would you expect to want the mustard? Because they are saying that 4 of last 6 customer. Okay, 4 of the last 6. How much total customer? 6. And how much the last 4 out of 6? So it means that 4 by 6 that wants to mustard on their hot dogs. So considering this data, how many of the next 12 customers? So 2 by 3 of the 12th, we are going to finding it out. Okay, 2 by 3 times Sorry, it's not. That is equals to n by 12. Okay, we're going to finding it out the ratio. Now just multiplying both the sides with 3. 2 by 3 times 3, n by 12 times 3. This 3 and 3 should be cancelled, only 2. Now multiply with 12 times 3 times 12 times 12. 12 should be cancelled. 12 times 2 is 24. That is equals to n times 3. Now moving here. So 24 is equals to n times 3, dividing 3 on both sides. This should be cancelled, and 3 times 8 is 24. So n is equals to 8, and that would be your answer. So now next is Annie surveyed 20 students at her school about their favorite colors. Of the students surveyed, 8 said black was their favorite color. If the Annie surveyed 5 more students, how many of them should she expect to pick black based on the past data? So there are total 20 students. How many students that are interested in the black? 8. So 8 by 20. And now 8 by 20 is equals to 5 by n by 5. You're going to finding it out like this way, and in this way you're going to write your answer. Okay, hope you guys understand this lesson as well. So let's discuss the last lesson of the day, which is compound events. Find the number of outcomes. Okay, so what are compound events in the probability? First of all, we can write this. What are the compound events? Compound events are basically involves the occurrence of two or more simple events. Okay, let's suppose, for example, simple event is single experiment like flipping the coin once. Compound event is involve two or more simple events like rolling a die twice or drawing two cards from a deck. Okay, like in the simple event we just flip a coin for once, but in for the compound events we are rolling the dice not only single time, for twice. We are drawing the cards twice, and that is from a deck. This is basically the difference between these two. Okay, let's suppose how to finding it out these compound events. For example, rolling a dice and then flip a coin. How many total dice? That are 6. And for rolling a coin, let's suppose first of all it's heads, then it's tails. Okay, so let's do it here. Now you pick a card and pick a marble. This is the card are given, and here are the marbles are given. So first you pick a card and pick a marble. So how many outcomes are possible? The first outcomes. Let's see this cards. Okay, this is N and that is O. So there are how many events? Two events. Okay. Now for the second, there are two marbles. So how many events? That are again two events. So for N, there are two possibilities. And for the O, this is also the two possibilities. Okay. And now this is P represent for the purple and O represent for the orange. Let's do it for N. And they also saying that make a tree diagram. Okay, so for there are two cards. This is N, and that is O. For N, there are two events, purple, orange. For O, this is two events, purple, orange. Now, first of all, this becomes N and P, N number card and purple color, N number card and orange color, O number card and purple color, O number card and orange color. So how many of it's 1, 2, 3, and 4? These are total 4 basically the things we have done. 4 branches, okay? So here there are 6 dice. For the dice it's 6. 1, 2, 3, 4, 5, 6. And for 1 it's F, G, H and I. It's 4 for the 1, 4 for the 2, 4 for the 3, 4 for the 5, 4 for the 6, 4 for the 7. 4 for the 6, sorry. Like how? This is a dice. You make a tree diagram like this with dice: 1, 2, 3, 4, 5 and 6. These are for the dice, and for each these are 4. I'm going to do it for each is 4. Okay, like this way I'm going to do it. 1, 2, 3 and 4. 1, 2, 3 and 4. 1, 2, 3 and 4. Like how many cards? F, G, H and I. Let's do it. F, G, H and I. So for this answer is F1, G1, H1 and then I1. For this answer again F, G, H and I. 2F, 2G, 2H, 2I. So 4 for this, 4 for this. Each is for 4. 4, 4, 4 for this, 4 this, 4 this, 4 this. So these are total 24. Okay, this is 6, this is 4, so when you're going to multiply that becomes 24. Understand? This is the way that we do it. Now here you flip a coin. There are two possibilities for coin only, head on tails. And how much of it? 1, 2, 3, 4, 5 are cards. So how much the events that are given? 5 for the first, 5 for the second. These are total 10. Why? Because 2 times 5 is 10. This is the possibilities, okay, for the events. Now hope you guys understand this lesson as well. So in that lesson we are just simply we are doing separately here or like that way. Okay, simple. These are the dices. We are putting the 6 dice are here and 4 cards. So for single we are going to, for 1 we are putting 4 cards, for 2 we are putting 4 cards, for 3 we are putting 4 cards, and then we write it all the answers. For 1 this is the answer, for 2 this is the answer, 3, 4, 5, 6, and then we get it. Hope you guys understand this lesson. So today we discussed the grade 8 maths probability chapter. Here the list of the lesson: identify the dependent and independent events, probability of simple events, probability of opposites, mutually exclusive and overlapping events, make predictions, compound events. We discussed this chapter again, okay? Because today we only discussed the little bit, and if you are more interested then we start from this and then we move forward in the next session. So you guys make sure to practice all these questions, and if you still need any help in any of the questions, you contact your tutors that are available. So you contact through this live chat button. Open this, put in your department and name, and then just send. In this way you directly contact with the tutors through this website. Hope you guys understand it. So see you in the next session. Have a great day, you all. Bye.